Okay, in this lesson, we're going to be factoring polynomials of the form ax squared plus bx plus c, where a, b, and c are integers. Now, we actually already did do this, but only for the case when a equaled 1, because we worked last lesson on polynomials that look like this, x squared plus bx plus c. But really, that meant there was a 1 times x squared there. Today we're going to be looking at the case where a doesn't equal 1. So it could be a 2, a 3, a -5, for instance. And when a doesn't equal 1, we use a method called decomposition to factor the trinomial. To decompose something is to break it down. So what we're going to do is break down the middle term, the bx part. We're going to break that down and then rebuild in a factored form. So let's take a look at this first example. The steps are listed to the left, and we're going to work on example 1, 6x squared plus 11x plus 4. The first step here is to find two numbers that multiply to get a times c. Okay, so you want two numbers that multiply to give you 6 times 4, which is 24. And those same two numbers need to add to get you the middle term, the b, which is 11. So two numbers that multiply to get you 24, add to get you 11, that's 3 and 8. 3 and 8. And with that 3 and 8, with those two numbers, we are rewriting the middle term of the equation. Okay, so we're going to take the 6x squared that was there. You still have 4 that was there in the end. But for the 11x, that part, we're going to use the numbers we selected, 3 and 8. So 3x plus 8x equals 11x. So we are taking these in order to rewrite that. And at this point in the process, you should see a pair of binomials. So here's one pair, 6x squared plus 3x, and here's another pair, 8x plus 4. What we're going to do with those two pairs is for each pair, we will factor out the greatest common factor. So let's take a look at the 6x squared plus 3x. The greatest common factor in that case would be 3x. So we'll have 3x, and then in brackets, 3x times 2x would give you the 6x squared. 3x times 1 would give you 3x. For the other binomial, 8x plus 4, we can factor out a positive 4, and then in brackets, 4 times 2x is 8x, 4 times 1 is 4. And at this point, you should see a common binomial. Look, you have 2x plus 1 here that's multiplying the 3x. You have 2x plus 1 over there multiplying the 4. So 3x and 4 are both being multiplied by the same factor. That means you can factor it out. We can now factor out the 2x plus 1. That's being multiplied by 3x, and it's being multiplied by positive 4, and that's your answer. You now have a pair of factors that multiply. If you multiplied it, would give you that trinomial. So we've just factored that trinomial. And just one note here, if you did not see a common binomial by step 3, then you must have done something wrong. So backtrack and see if you had any errors in the previous step. Okay, let's take a look at another example. So I still have the steps on the left. If you feel like you're comfortable with it after just one example, why don't you go ahead and try it out? And for the rest of you, just walk through it with me. Our first step is we want to find two numbers. Two numbers that will multiply to give 12 times -6. 12 times a -6, which is a -72. And then those two numbers also must add to give you the middle term, the -1. We know 8 times 9 is 72, and then 8 times a negative 9 would be negative 72, while 8 plus a negative 9 equals negative 1. And remember, the point of those numbers is to rewrite the middle term. So we want to rewrite this negative 1x in our original expression. So we'll take our 12x squared. The middle term is what we rewrite with those two numbers. The middle term, we'll rewrite it with a positive 8x and a negative 9x. And then you had the negative 6 as well. At this point, split into two binomials. And then for each binomial, factor out the greatest common factor. For that 12x squared plus 8x, we can factor out a 4x. So 4x times 3x equals 12x squared. 4x times 2 would equal 8x. For the negative 9x minus 6, we can factor out a negative 3. Negative 3 times 3x would equal negative 9x. Negative 3 times a positive 2 would equal negative 6. And we know we're on the right footing at this point because we see a common binomial. So the last step would just be factor out that common binomial. 3x plus 2 being multiplied by the 4x and the negative 3. And that would be your answer. Now, if you wanted to, you could test this out. With any factoring, you can always test to see if you're right or wrong. All you have to do is multiply your factored form and make sure it looks like the original form. So let's do that. 3x squared 3x times 4x is 12x squared. 3x times a negative 3 is a negative 9x. 2 times 4x is a positive 8x. And 2 times negative 3 is negative 6. Then simplifying, you'll have 12x squared minus x minus 6, which is the same as what you started with, so you know you are correct. Okay, let's do another example where I walk through it pretty slowly. 2x squared minus 5x plus 3, let's factor that. First step, find two numbers, then multiply to give the first times the last. So 2 multiplied by 3, which is 6. Those same two numbers need to add up to give the middle, which is the negative 5. So let's see, negative 2 times negative 3 is 6. And negative 2 plus negative 3 is negative 5. What do? We use those numbers to rewrite the middle term. So we have our 2x squared. The middle term is what we're rewriting using the numbers we selected. So we have negative 2x and minus 3x. That was us rewriting the negative 5x. And you have the plus 3 on the end there. At this point, you have a pair of binomials. Factor out the greatest common factor of each binomial. For the first set, you have 2x, and you can factor out an x minus 1 there. For the second set, you can factor out a negative 3, and then you'll have x minus 1 as well. And at this point, we see the common binomial, the x minus 1, so we know we're in good shape. 2x and minus 3 are both being multiplied by x minus 1, so we can factor that out. X minus 1 multiplied by 2x minus 3. And that is our factored form. Now some of you might be asking, what if I rewrote the middle term another way? What if instead of writing 2x squared minus 2x minus 3x plus 3, we wrote 2x squared minus 3x minus 2x plus 3. So what if we swapped places with those two? Well, you're going to end up with the same result. And let's just walk through that in red here, just to show you. At this step, what did we do? We looked for a pair of binomials, and we're going to factor out the greatest common factor of each. For the 2x squared minus 3x, we can factor out x, and then we'll have 2x minus 3 in brackets. For the next pair of binomials, factor out a negative 1, and then you'll have 2x minus 3 in your other set of brackets. Again, you find a common pair of binomials, and that's what you factor out. 2x minus 3, that was being multiplied by x minus 1, and those two are equivalent. So this is correct, and this is correct, because with multiplication, order doesn't matter. So as long as you select the correct two numbers, the negative 2 and negative 3, and go through the process, you're going to end up with the correct answer, whether or not you wrote regardless of the order that you wrote those two numbers. Okay, so let's go through a few more examples and we'll pick up the pace a little bit. So for example 4 there, 6x squared minus 16x minus 6, before we just jump into it, remember that with any factoring, the first step is to factor out a greatest common factor if there is one. And for number 4, there is, because 6, 16, and 6 are all divisible by 2. So the greatest common factor equals 2. So the first step is to factor that out. Take out the 2, then you'll have 3x squared times 2 is 6x squared. 2 times negative 8x is negative 16x. And 2 times negative 3 is negative 6. So now let's go ahead and factor what's in these brackets here. We want two numbers that multiply to give us 3 times negative 3, which is negative 9. Those same two numbers we want to add to give the middle term the negative 8. Those two numbers would be negative 9 and 1. Negative 9 and 1. So we're rewriting that middle term. We have 3x squared minus 9 plus 1 x minus 3. And we can't forget that that 2 is multiplying all of that. Now within the brackets there you have your two sets of binomials. Factor out the greatest common factor of each. For the first set it would be 3x, x minus 3, and then factor out a plus 1. Then in brackets you can have an x minus 3, and again, never forgetting that you have the 2 multiplied by everything there as well. I should put some big square brackets there. Within the brackets again, we see a common pair of binomials, so we can factor that out. X minus 3 being multiplied by 3x and plus 1. And again, can't forget your 2. So 2 multiplies all of that. And that's your final answer. 2 times x minus 3 times 3x plus 1. Now number 5 doesn't have a greatest common factor. There's no number that divides evenly into 8, negative 18, and negative 5. So we can just jump straight into our process of finding two numbers that multiply to give us 8 times negative 5, which is negative 40. And those same two numbers are going to add to give the middle term, which is negative 18. Negative 20 and positive 2 should work. Negative 20 and positive 2. We use those to rewrite the middle term. So we'll have 8x squared. The middle term we'll rewrite as negative 20x plus 2x. And then the last term is the negative 5. At this point, we pair up binomials and factor out the greatest common factor of each pair. For that first pair, we can factor out a 4x. And in brackets, we'll have 2x minus 5. And the last pair, there's no greatest common factor. We can just factor out a positive 1 then. And you'll have 2x minus 5 in brackets. You have a common binomial, the 2x minus 5, which you can then factor out because it's being multiplied by 4x and by positive 1. And that would be your answer there. For example 6, we want to do a couple of things before we start the process that we've been practicing. And the first is to rewrite the expression with the x squared term in front. So we'll write that negative 12x squared first, and then the negative 10x, and then the positive 12. Then we'll factor out the greatest common factor. Each of those numbers is divisible by 2, but what we'll do is we'll factor out a negative 2 so that the x squared term can be positive when we factor. Negative 2 times a positive 6x squared equals negative 12x squared. Negative 2 times negative 5x, or times a positive 5x, is negative 10. And negative 2 times a negative 6 is a positive 12. So we factor out that negative 2 so that that x squared term can be positive. Now we do our process, which is find two numbers that multiply to give you the first times the last term. 6 times negative 6, which is negative 36. And those two numbers need to add to give you the middle term, which is a positive 5. Two numbers that will work would be a positive 9 and a negative 4. Positive 9 and a negative 4. Okay, so we still have our negative 2 from the outside there, and we're rewriting or factoring out the term in the brackets. 6x squared plus 9x plus 4x minus 6. We look for our pair of binomials, and for each pair, we'll rewrite the greatest common factor. So we have our negative 2 still. And then for the 6x squared plus 9x, we can factor out a 3x. So 3x times 2x is 6x squared. 3x times a positive 3 is a 9x. For the 4x minus 6, we can factor out a positive 2. And a positive 2 times 2x is 4x. 2 times a negative 3 is a negative 6. We see our two common binomials, and we can factor that out. Still keeping in mind we have that negative 2 on the outside there that's multiplying everything. And you have your 2x plus 3, the common binomial, multiplied by the 3x plus 2. So your final answer is negative 2 times 2x plus 3 times 3x plus 2. Okay, let's look at example 7. I think the only thing unique with this example is you're using g's instead of x's. No problem, the process is the same. We're going to look for two numbers that multiply to give us the 6 times the negative 4, which is negative 24. And those same two numbers need to add to give the middle term, which is 23. Two numbers that'll work would be negative 24 and 1. Negative 24 and 1. And what do we do with those two numbers? We use them to rewrite the middle term. So we'll have our 6g squared minus 24g plus 1g minus 4. At this point, pair up your binomials and find a greatest common factor for each. For the 6g squared minus 24g, we can factor out a 6g. And then in brackets, you'll have a g minus 4. For the second binomial, you can just factor out a positive 1. And again, in brackets, you'll have a g minus 4. Now you see you have a common binomial, g minus 4. Factor that out. G minus 4 is multiplying 6g and positive 1. And that is your factored form. Okay, in these two examples, there's a little bit of a twist. It is not telling you to factor them. It's saying find all the possible integers to replace k so that the trinomial can be factored. Well, the way to think about this is, what's our first step if we were to factor? Well, we would have started by getting two numbers that multiplied to give us the 3 times the -4, which is -12. And those same two numbers would need to add to give you the middle term, which is your k there. So you're trying to find all the ways to get k. So what you need to find is all the numbers that can fit into here and here. So we're basically listing factors of -12. So let's do that. Well, let's start with factors of +12. You have 1 times 12 is 12. 2 times 6 is 12. 3 times 4 is 12. But we're looking for -12, so one of those has to be negative. 1 times -12 is -12. 2 times -6 is -12. And 3 times -4 is -12. But that opens up the possibility that maybe that second column of numbers wasn't the negative. Maybe it was the first column. So you could also have -1 times +12, -2 times +6, or -3 times +4 being equal to -12. How do you get k? You get k by adding those two factors. So let's add all this and see what we get. So 1 plus a -12 is a -11. 2 plus a -6 is a -4. 3 plus a -4 is a -1. -1 plus 12 is a +11. -2 plus 6 is a +4. -3 plus 4 is a +1. So all those integers in red, all these integers in red are the possibilities that k can be for that trinomial to be factorable. And it's the same process for example 9 there. You would have started off, if you were going to factor this, by looking for two numbers that multiply to give you 5 times 8, which is 40, and those two numbers would add to your k. So to figure out what k is, you need to figure out what all the factors of 40 are. And we can list them out. 1 times 40 is 40. 2 times 20 is 40. 4 times 10 is 40. And 5 times 8 is 40. But we can't forget, to multiply to a positive number, you can also multiply two negatives. So other pairs could be -1 times -40 is 40. -2 times -20 is 40. -4 times -10 is 40. And -5 times -8 is also 40. To figure out what k is, we're adding those factors. So we'll add each of these. And once we have the sum of all of those would be our possibilities of k. So we'll have 41, 22, 14, and 13. And then also -41, -22, -14, and -13. These are all possible integers that k could be for that trinomial to be factorable. Okay, last two examples, and these are relatively quick. For this question, it says, find only one possible integer that could replace that letter k for that trinomial to be factorable. And we think about this again the same way. If we were doing this, we would be looking for two numbers. If we were to factor that expression, we would be looking for two numbers that would multiply to give you k, and those same two numbers would add to give you 8. So you're just looking for two numbers that would add to give you 8 and then multiply those numbers. Well, 7 plus 1 equals 8. To get k, I'm supposed to multiply those factors. So 7 times 1 equals 7. So k can be 7. Example 11. Same story. If we were going to factor that trinomial, we would have looked for two numbers that multiply to give k. And those same two numbers would have added to give negative 5. So all we need to do is look for two numbers that add to give negative 5. Well, negative 6 plus 1 gives you negative 5. In order to find k, we just multiply those two numbers. So negative 6 multiplied by 1 gives negative 6. And that's a possible integer that k could be.